So good morning everyone. So we are again with organic chemistry, that is part 2, that is the lecture number 2 here. And that includes that the previous lecture, that is the study of hydrocarbons, is the organic chemistry, and about their derivatives. Derivatives includes few of the elements that either the nitrogen, oxygen, sulfur, or maybe the halogens are present there, right? And about the second most important thing that we understood from the lecture number 1, that carbon atom must have a maximum valency of the 4 bonds, that maximum to this it must contain the 4 bonds. Second, the unique nature of the carbon atom, that the unique nature, by this unique behavior it will show you the tetravalency, and secondly it will show you the catenation property. What you understand by the catenation property? It means the self-linking capability of the carbon atom. That means the self-binding property of the carbon atom, that the carbon atom is combining with itself again and again. That property of the carbon atom is the unique nature, that's its catenation property. Now next is about its tetravalency. Now in the case of tetravalency, it is said that the carbon has a maximum covalency of 4. That means it requires only 4 electrons to complete its last valence shell, and already it is having the 4 electron in its last valence shell. So that's the property, unique nature of the carbon atom only, which is shown by the carbon only. And next is the organic compounds always containing covalent bonds between them, as we already studied about this HCN compound, that it's an inorganic compound, not the organic one, because it is containing the ionic bond present with the atoms. Although the atoms present all are showing the properties of the organic compounds, like the hydrogen that present in the organic compounds, a hydrocarbon, that is the carbon is present, and also along with nitrogen is present. So after looking at the atoms, we always conclude that it's an organic compound, but due to the presence of this ionic bond that is not included in the organic, it is always an inorganic compound. Okay, so I hope you understand the basic properties and the basic nature of the organic compounds as well as of the inorganic compound, and also about its history, about its how the history persisting or history containing the organic compound, and how important the organic compound for us are in our daily life and in our routine life. Now further, a very unique property of the carbon atom is that it has the tendency to form the multiple bondings with the atom carbon itself, and secondly with the other atom of the compound. Either the other atoms are nitrogen, oxygen, or maybe the sulfur is present there, etc. These are the atoms present. So here, if the carbon to carbon self-linking part, they are containing a single bond present among them. Okay, maybe that carbon to carbon single bond is present. So this is the single bond present with the carbon to carbon atom. Maybe carbon to carbon atom double bond is present. 2 bonds are present there, 1 and 1 to 1 this side. Maybe that double bonding is present with the carbon atom. And further, maybe the double bond is present among the carbon atoms. And further, there is a formation of triple bond also present with the carbon atoms. Okay, one bond, if one bond line is present, that is called the single bond present. If 2 bond lines are present, it is called the double bond. And if 3 things are present, then it is called as the triple bond. And remember always this thing, that if 2 lines are present among the 2 carbon atoms, that this carbon atom further requires 2 extra bonds to complete its 4 valency, and also this carbon also requires 2 extra bonds to complete its 4 valency. Now as you see in the case of triple bondings, 1 carbon containing 1, 2 and 3 bonds, and further it requires the 4th extra bond. Same with this carbon, 1, 2, 3 are present among the 2 carbon atoms, and it requires the 4th bond to complete its 4 bonds now. Okay, we can take any of their examples also. Like in the first case, we have an example of ethane, 1 CH, this is the CH, 1 CH is present, single bond carbon, then we have 3 hydrogen atoms along with this. Okay, that is the case of, this is known as your ethane gas, that is called as ethane gas. Now in the case of carbon, double bond carbon, so here we have carbon, double bond carbon present. So another which is with the thing that is present is the hydrogen atoms present along with this the carbon atoms. So now this is called as ethene gas. Okay, that is the ethane gas present. Now next is called as the ethene gas, which is containing the carbon, double bond carbon atom. Now the third and the last example for the triple bonding is carbon, triple bond carbon is present. One hydrogen is over there, second hydrogen is along with this carbon. Now this triple bond carbon and triple bond carbon is named as ethene gas. So there is the names present with them, that is the ethane, ethene and ethene gas. So now the question arises in that how many types of compounds can a carbon atom and the hydrogen atom along with their derivatives can have. So they have many types of compounds. Let's study the types of compounds present along with the carbon, hydrogen and with the other atoms in the organic compounds. Okay, the very first thing we are discussing about the hydrocarbons present with them. So in the case of hydrocarbons, which means the compound which will contain only the carbon and the hydrogen atom. So we have three categories, or we can simply say that we have three types of families present in the hydrocarbons. The first family, which is known as your alkane family. The first family is called as the alkane family. The second case we are saying it to as alkene family, right? And in the third case, we are saying is to as alkyne family present, or we simply said it the alkynes are present here, right? Now in the alkane, right? In the case of alkenes, the carbon to carbon single bonds are present always. If the single bonds are present, then all the compounds which are containing only the carbon to carbon single bond, they are included in this category, that is the alkenes or the alkene family. Either we can also call them as alkanes only, that is also fine, or we are continuing as the family that is called as the alkene family. That all the compounds must containing a single bond between the carbon to carbon atom. That is, this is the CH3. That is the CH3, here the CH3, again here the CH, H and CH3. So these two carbon atoms containing only the carbon to carbon single bond, that's why they are included in the alkenes, right? This is the alkenes present. Now, if we are talking about the alkenes, that is known as the alkene family. Okay, that is the alkenes present here. The carbon, double bond carbon can be present. Okay, can we not? It is the must condition. If the carbon, double bond carbon is present, either it is the one among all the chain, or maybe 2, 3, 4, whatever the double bond count it is, but it is a must requirement, that is a minimum requirement, that the chain, the branch chain or maybe the cyclic ring of the carbon atoms must contain a single double bond among them, that is known as the alkenes. For example, I can take the example of the alkenes. For example, 3CH3, this is the CH2 and this is the CH2. Now we have CH double bond and this is the CH2. As you see this thing, please see this thing up. This CH3 containing 3 bonds of these carbon atoms are complete by the hydrogen atom, and 1 bond is completed with this carbon atom. Same with the second number carbon, 2 bonds are compiled with this carbon and 2 are completing with these hydrogen atoms, and same with this carbon, same with this. Now coming on to this carbon, okay, that is the 4th number carbon, 1 bond is completed with this carbon bond, second is compiled with this hydrogen, and next 2 are compiled with these carbon atoms, and 2 bonds are present among the carbon atoms. That's why it is included in the carbon to carbon family, that is the alkene family. So we can also write up these complete compound in the open up form like this. We have 5 carbon atoms, 2 bonds are present there. So we have one hydrogen over there, one over there. Here also we have one hydrogen. Here we have two hydrogen atoms present. Here we have two hydrogen atoms present, and here we have the three hydrogen atoms present. So that's known as the open structure. This is called as the open structure present. You can write it up, this open structure, in the condensed form. That is the condensed form present. So you can also write this open structure in the condensed form. Just write up all the hydrogen atoms together, that the three hydrogen atoms are present. Write up the second two hydrogen atoms together, then again the two hydrogen atoms. Next also we have a one hydrogen atom, double bond carbon, and this CH2 is present. So we can also write it this formula in this condensed form, or maybe you can write up the formula in this open structure also. So both the formulas are right for that. Okay. Now this, because of this molecule containing a double bond, that's why it is including in the alkenes, that the alkenes are present there. That's it is named as, that's an alkene compound. Complete compound is known as an alkene compound present here. Okay. Now this is the case. Now coming up to the next family, that is called as your alkyne family. The last one part which is present, which is known as the alkynes. In the case of alkynes, carbon triple bond carbon is present. If this case is present, that the carbon triple bond carbon is present, that is called as the alkynes. Okay. That is the must condition. Either it will contain 2, 3, 4, 5, how many alkyne triple bonds can be there, but one triple bond must be present in them. That is called as the alkynes. For example, we can take an example of CH3, then we have CH2, then we have C, triple bond C, and that is the H present. Again, this is the condensed structure I am writing here. You can write it up in the open form also. So here, as you see, we have this carbon atom containing triple bond with this carbon atom. So please remember this thing. Just look at the number of bonds that every carbon atom must contain over there. That every carbon atom containing the maximum of 4 bonds, not less than the 4 bonds and not more than the 4 bonds. So this is the basic mistake every child is doing while writing the chemical formulas of the organic compounds. They are not looking at the bonds present with the carbon atom. As we studied in the first lecture, that the must condition of this carbon atoms is their tetra valency, that they only contain the 4 bonds along with them. Okay, so please remember at this 4 bond concept, the 4 bond is present with the carbon atom, not more than the 4 bonds and not less than the 4 bonds. Okay, now this complete compound is included in the alkyne family. Why it included in the alkyne family? Because it contains a triple bond in them. That's why it will include in the alkyne family. So these, either we are talking about that alkene part, which will contain a carbon to carbon single bond only. Okay, either we are talking about that alkenes part, which will contain the carbon to carbon double bonds, and either we are talking about that the alkynes part, which is containing carbon to carbon triple bonds with them. They all are includes in the hydrocarbons, because they all are containing only the hydrogens and carbons among them, not other than any of the part which is different from this hydrocarbon. So next, about the compounds, we are studying those compounds which include further things from the hydrogen and carbon parts. Okay, we are discussing the rest of the compounds here. Now next, after these hydrocarbons, we are including with the other compounds, that is including the rest of the heteroatoms, that is oxygen. Okay, and that may include the extra of the halogens with them, that the nitrogen and sulfur, that is not the part of your syllabus. The few topics are only included in syllabus that we are going on to them, and the rest of the topics you are going to study in your class 11, that is the organic chemistry, that is vastly present there. Okay, now the first member is known as your alcohol, and in the alcohol the main part that is present is OH group, that is must be present along with this hydrocarbon. And if you want to take the example of that example is included, that CH3OH, maybe that CH3CH2OH, that is also the example of the alcohol present. Okay, this is the case. We are going to start their study in deeper. Here also that second case is known as your aldehyde. That aldehyde must contain a CHO group along with your hydrocarbon part, that it includes the CH3 and CHO there, or maybe it is that CH3, CH2 and further the CHO part is present there. So that is called as the aldehydic part. Now next part that is present here is known as the ketone part. The ketone is present there. It must include a bond of C double bond O group in your hydrocarbon, right? The example is that CH3C double bond O and that CH3 part is present. This is called as the ketonic part or the ketone part. That this example must containing a C double bond O group. This further that aldehydic part, that is a CHO group, this example containing a CHO group, and alcoholic part they must contain an OH group, that is the OH group is present along with them. So these are the examples and the few of the things about the other members also rather than the hydrocarbons present with them. Now moving on to the next case, that is known as your carboxylic acids present. Okay, I hope you people are knowing about the carboxylic acid. I'm just giving you the group, that is COOH group, which is present along the in the case of carboxylic acids. An example given is that CH3. This is the COOH part. This is, you know, that is your acetic acid, right? You are aware from this acid, which is known as your acetic acid, which is called as your acetic acid present. That is that you are aware from this acetic acid, which is also known as your vinegar. Okay, this is the acetic acid present, and yes, this acetic acid is an organic compound containing the carboxylic acid group, that is the COH group along with this case. Okay, right? This is the case. Now next case is present as your ether. In ether, the part group is present as C, O and C group, which is present over there. And we are also called, example we are taking it at CH3O, and this is the CH3. Where this O group is present in between the two these hydrocarbon compounds, that is called as your ether group, and this is compound is called as your ether, right? Now further we have some of our halides. Halides means that we have some of the halogen parts. Maybe we have the fluorine, maybe we have chlorine. If suppose we have fluorine, then we are just providing it's a fluorine, chlorine, bromine, iodine, any of the thing is present. Fluorine, chlorine, bromine or iodine, any of the thing is present. Suppose we have fluorine, then its compound is as CH3F. If we have chlorine, then CH3Cl. If we have bromine, then this compound is CH3Br. Suppose if we have iodine, then this compound is CH3I. These are the compounds present here. Again, I am just giving you a brief discussion for these structures and the compounds. Thus, first we have our alkanes, right? It means the carbon to carbon single bond is present in the alkanes. Secondly, we have our alkenes. Here also the carbon to carbon double bond is present, right? And then further we have our alkynes. In them, carbon to carbon triple bonds are present, right? Further, after to them, we have alcohols. Where in the alcohols, among then the hydrocarbons, there must be present an heteroatom, that is your oxygen, that is the OH group present, or we can take any of the example of the alcohol part, right? Now from further from this alcohol we have aldehydic group, that is the aldehydes are present. In the aldehyde the main group is present as CHO, and the example is taken as CH3CHO, that is the aldehyde present, right? And from the further to this aldehyde we have ketones. In the ketones the must group is present is C double bond O group, and example we can take as CH3C double bond O, and this is the CH3 present. Okay, and after this ketone we can also move on to the carboxylic acid part, that is the carboxylic acid which is present. And the best example and the group present with the carboxylic acid is the COOH, and the example taken is the CH3COOH part, that is the carboxylic acid present over there. Okay, and next to the carboxylic acid we have the ether part, that is your called as O and O. This is the O part. O is present between them. That one CH3 is present over there, one is CH3 is over there. The O part is present, which is called as the ether part. And after this ether, we are studied the halogen compounds. That is, if maybe the fluorine is present, chlorine is present, maybe bromine is present, or maybe the iodine atom is present. Okay, so remember these things. If fluorine is present, then we can take its example as CH3F. If bromine is present, chlorine is present, so we can take their example as such. The bromine is present there, and maybe the iodine atom is also present there. Okay, so these are the cases where we have their structures and where we have their values of their hydrocarbons and about the different types of compounds present along with us in the case of our different type of heteroatoms present, that is the derivatives of the hydrocarbons according to the definition of the our formula. Okay, right? Now in the syllabus, next we have about the structure formulas of the hydrocarbons, and with that structure formulas must be given for the alkanes, alkenes, alkynes only up to 5 carbon atoms only. Okay, we are gonna to study about the simple structure formulas of the organic compounds, that is your alkanes, alkenes, alkynes up to the 5 carbon atoms only. Okay, so let's start their organic compound structure formula. So here we are discussing the structure formulas for the 3 compounds, that is the alkanes family, second is for the alkenes, and the third is for the alkynes case, right? These are the 3 cases. So first, in the case of alkenes, generally a formula is used for the whole of the compounds to know about their formula. Okay, for example, we have Cn, that is equals to Cn H2n plus 2. Okay, that used for the complete alkane family. Here n represents you the number of carbon atoms present. Okay, it will give you a condensed formula value. Okay, now I'm giving you the example for that. Suppose we have n value is equals to 5. Okay, then put this n value over in the formula and we will receive C5 H2 into 5 plus 2. Now finally the formula is C5 H12, right? It means that over 5 carbon atoms we have 1, 2, 3, 4 and 5, and 12 hydrogen atoms we have. Just go and complete that 4 bonds of every carbon atom present over there. So 1, 2, and this is 3. Again 1, 2, again put that 1 and 2. Here also we have 1 and 2, and here we have 1, 2 and 3. You can go and just complete their value and just count down the number of hydrogen atoms present there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So that's the formula given for the number to write down the hydrocarbon, that is your alkane, and the formula name is your CnH2n plus 2 only. This is the formula present. By this formula you can calculate the value of or the formula of the any alkane containing the any number of carbon atom. So next we can calculate for the second number. If n is equals to 2 here, so we can write it as C2 H2 into 2 plus 2. The value is equals to C2H6. So here we have 2 carbon atoms that must contain the single bond present between them, because as the name suggests, they are from the alkane. So they are always containing the single bonds among the carbon atoms. Okay, so this is the case, that is CH3. The cases are present there, and this is the CH3 are present here. So how we comes to know that how the number of hydrogen atom every carbon atom can contain? So it is purely based on the thing that every carbon atom can contain a maximum of 4 bonds. So please go and look at the number of carbon atoms present and the number of bonds present among them. Let's suppose take another example. We have n value is equals to 7. Then by putting in the formula C7 H7 into 2 plus 2, the total value is equals to C7 H14 plus 2, it is equals to H16 value. So firstly we have 7 carbon atoms. So just make a single bond among each carbon atom, and you just need to make 7 carbon atoms here, right? You are just drawing the 7 carbon atoms, and thereon you are preparing you are just putting the hydrogen atoms on them with the single bonds with every hydrogen atom. 1 and 1. On the terminal ends, we have 3 hydrogen atom with every carbon atom, and then in between the carbon atoms, we have 2 hydrogen atoms only, because the carbon valency is completed by the 2 carbon atoms and the 2 hydrogen atoms here, right? So here we have the 2 hydrogen atoms in between the formulas. Now the total count is 16 only. Here we get the formula, and you can also write it up its condensed form as such. This is CH3. In between we have CH2, CH2, this is CH2, 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 and finally we have CH3 over there. Okay, this is the complete formula present here. Now this is the first case, that is representing the alkane family. Now moving on to its second case, the second case which is representing about the alkenes members, the members in which 1 carbon to 1 carbon double bond is present. Okay, that is the must condition. Carbon double bond carbon must be present over there. Then the formula used is CnH2n. Okay, in the case of alkanes, the formula is CnH2n plus 2, but in the case of alkenes, its formula used is CnH2n only. Okay, now in this case, as you see, the formula is CnH2n. So in that respect here, just suppose we have n is equals to again 5. Now the formula is Cn, that is 5, then H2n into 5. It means it is equals to C5 and H10. So we have 5 carbon atoms. So first made 5 carbon atoms with the single bonds present between them. And we know this thing, we are talking about the alkene family. It means 1 double bond must be present among all the 5 carbon atoms. So you can take a double bond at any position. Maybe this side, maybe this, maybe this, or maybe this. That is not an issue with that thing. Okay, ये कोई issue नहीं है इस चीज में. You can take the double bond at any position. So here, just now completing the 4 bonds of every carbon atom. The 3 hydrogen atoms to be put there, 2 hydrogen atoms to be putting there, 2 are coming this side, and 2 hydrogen atoms are comes to be here. Now 1 hydrogen atom coming here, and rest of the 2 hydrogen atoms are coming on this position. Now count down the number of hydrogen atoms present. The total number of hydrogen atoms present are 3, 4, 5, 6, 7, 8, 9, 10, and 11 and 12. So how this thing is possible now? That the 12 hydrogen atoms we are getting here, and here the formula is given, shown you that CnH2n is over there. Just see if any mistake we had making there. Any mistake is present there. See this thing. We have here 6 carbon atoms present. 1, 2, 3, 4, 5 and 6 carbon atom. That's the mistake we make here. So remember this thing always. These formulas are always right. That the number of atoms are shown by these formulas are always the right number of atoms. So we have 1, 2, 3, 4 and 5. So double bond is present there. So 1 hydrogen atoms, 1 hydrogen atom over there. Again 1 hydrogen is there. 2 hydrogen atoms are present there. 2 hydrogen atoms along this carbon, and 3 hydrogen atoms are present with this carbon atom. So now count down. It is the formula containing C5 and H10 only. That's the case of alkene, where the 1 carbon to carbon double bond is present with along with the formula of CnH2n is present over there. Right? This is the case present. Now, in the case of alkyne, when we are talking about the alkynes, in the case of alkynes, then 1 carbon to carbon triple bond must be present in the formula, and the compound's formula is that the general formula is CnH2n minus 2. And now if we are taking an example of n value, suppose I just take the n value is equals to 8. Okay, then the formula is C8 H8 into 2 minus 2. Then it is equals to C8 at equal to 14. 8 to the 16. 16 minus 2 is equals to 14 value. Then C8 1, 2, 3, 4, 5, 6, 7, and this is the 8 case. Right? Now just we know this thing, that in the case of alkynes 1 triple bond must be present there. So I can put the triple bond at any position. Suppose I put the triple bond over here. Just now after putting the triple bond, now I need to complete the 4 bonds of every hydrogen, every carbon atom. This is 1, 2, 3 and 4, right? And here also we have 1. Okay, it is, I'm writing here wrong, because it is present with the carbon atom only. So that's the bond is present along with the carbon atom only. So this is the hydrogen. Here also we have 1 hydrogen over there. 1 is there. one, you know, you just remember this thing. Just look at this thing. Three hydrogen atoms are there, two hydrogen atoms are over there. Now look at this thing. I'm just putting a hydrogen atom over this carbon only, but these carbons, as these carbons are having double bonds along, triple bonds along with them, 1, 2 and 3, and 1, 4 is completed by this side. So it means they already have 4 bonds, they're completed, so no need to put extra hydrogen on them. Just after putting extra hydrogen, I am making a 5th bond with the carbon atom, but I know this thing that the carbon can only show the 4 bonds only, so no need to put an extra hydrogen atom on them. Just count down the number of hydrogen atoms. 3 and 2 5, and 3 and 2 5, 5 and 5 10, and the 4 are there, that is the 14 count is there. So it means that we have carbon atom 8 and hydrogen atoms equals to 14 over there. So it means that is can be calculated by this formula. By the putting the value of carbon atoms with them, we can calculate the value of any of the family members of these families, like the alkane, alkene and alkynes. And in our syllabus, only the up to the 5 carbon atoms are present, that we can only calculate for the up to the 5 carbon atoms. But from this formula we can calculate for the any value we want. Suppose we want to calculate for 3 of the things, either for the alkanes, for the alkenes and for the alkynes, with their general formulas, the formulas which are including you CnH2n plus 2. This formula includes CnH2n, and this is the formula CnH2n minus 2. Here the n value represents the number of carbon atoms present with them. And if you want to, suppose if you want to calculate for n is equals to 100 value, then alkane formula become as C100 H200 plus 2. It means the formula is C100 H202. Now in this case C100 H2n, it means H is equals to 200 value. Then the formula is C100 H200 over there. Now in this case the formula is C100 H2 into 100 minus 2. Here the formula is C100 H198 is there, right? So these are the 3 formulas for alkane, alkenes and alkynes. Alkanes means the carbon to carbon single bond, alkenes means the carbon to carbon double bond, and alkynes means to you the carbon to carbon, the triple bond is present over there. Clear? I hope all these things are fine to you. So this is about the alkanes, alkenes and alkynes, and in the next video we are going to discuss about the functional group that is present with the different hydrocarbons, and secondly we are discussing about the isomerism and the homologous series of the organic compounds. So till then, take care. Please go and read this chapter from your book, and we are see you in the next video. Thank you.